Okay, so this is where we finished off last time. Let's complete the checklist for this problem. You remember that the function f of x is equal to 3 over x cubed plus 1. That's what we're trying to find the features of and graph. And we made this diagram last time. So let's finish up parts E through G and then graph the function. To finish up part E, we basically just have to make some statements about these intervals. I need to determine where is the graph increasing, decreasing, and constant. Well, I can tell by the sign of the first derivative, because it's negative in every single one of those intervals, that it's actually decreasing in every single one of those intervals. It's decreasing here, it's decreasing here, and it is decreasing here. Okay. Now let's go on and finish up part G. I need to figure out, well, first of all, is the graph concave up or concave down in each interval? I know because the sign of the second derivative is negative in this interval, it's concave down there. Because the sign of the second derivative is positive here, it's concave up there. Concave down here, second derivative is negative. Concave up here, second derivative is positive. Okay? And I can determine from that, are there any inflection points? Well, it looks like here, the sign of the second derivative changes. So this is certainly an inflection point. It changes from being positive to being negative. And also here, second derivative changes sign. So this is an inflection point as well. Changes from negative to positive. So the concavity of the graph changes at that point. What about this point? Well, the concavity the concavity does change here. However, this value, as we stated before, is not in the domain. So it can't be an inflection point. It is not a point on the graph. So I will say it, go ahead and say it here. This is not in domain. It is not an inflection point. In fact, we stated before that this is the location of a vertical asymptote. Vertical asymptote. Okay. So the other thing that we might want to do is figure out, well, what are the y values at those inflection points? I'll go ahead and tell you that. I know that I can figure out that f of 0 is equal to, I already figured that out, it's 3. Happens to be the location of the y-intercept. And f of the cubed root of 1/2, I'll let you do the calculations for it, that's equal to 2. So the point cubed root of 1/2, 2 is an inflection point. Okay, let's go back and do f. Since we have completed parts G and E, I'll write down the summaries here. This is 0.03. This is point cubed root of 1/2, 2. Let's do part F, where I classify any relative max or min. We'll notice above that the sign of the derivative, the first derivative, never changes. Also notice below that if I tried to, say, use the second derivative test on this critical point here, f prime prime of 0, well, I know what that is. It's equal to 0. I already calculated that. So the second derivative test fails. Second derivative test fails to classify that critical number x equals 0. But I can tell from the first derivative that because this graph is decreasing everywhere, that this point is not the location of a max or a min. So this is not a max or min. Okay. But I do know that the graph has a horizontal tangent at this point. So what it'll probably look like is it'll be decreasing, and then it'll kind of flatten out and then decrease again. Something like that at that point. And the graph is decreasing everywhere else. So we have all of the features. Let's put this on a graph. Okay. And make it a relatively simple graph. Okay. So let's put all of those relevant features first. I'm going to put the inflection points on there. I know I have an inflection point at 0, 3. Right there. I have another inflection point at, I'll go ahead and mark that. This is inflection point at 0, 3. I have another inflection point at square or cube root of 1/2, which is about 0.82, which is right there. It's an inflection point. Okay. The critical point or critical number is the same as the inflection point. Okay. One other feature I have is there's a vertical asymptote at -1 at x equals -1. I also had a horizontal asymptote. That's at y equals 0. Y equals 0. That was a horizontal asymptote. Okay. Now I want to bring in the features of my derivative. Where's the graph increasing, decreasing? Where is the graph concave up, concave down? I know the graph is decreasing everywhere. Okay, it's going down from left to right everywhere. I know that the graph is concave down from -infinity to -1. So here, the graph is concave down. Okay. I know from my line graph that I drew before that here from 0 to, or from -1 to 0, the graph is concave up. I know from 0 to cube root of 1/2, the graph is concave down. And I know for the rest of its domain, the graph is concave up. I also know a little bit about the behavior of the graph around this asymptote. I know that the function approaches -infinity. As it approaches -1 from the right, it approaches +infinity. As it approaches -1 from the left. That is probably enough for me to make a good sketch. Okay, it's approaching -infinity here. And I know it has to approach this horizontal asymptote out here. It does not cross it. We already determined what all our intercepts are, that there were no x-intercepts. Okay. On the other portion of the graph, I know, first of all, this is a place where the function kind of goes flat. The slope of the tangent line is horizontal. I know the graph is concave up here, and it approaches -infinity as it approaches that asymptote. Okay. Graph is decreasing and concave down here until it hits this point, and then it changes to being concave up, and then it has to, oops, I should probably not have it cross the axis. It approaches this y-axis, but never crosses it. Goes that direction. I'm going to make this slightly less curved. There we go. And that is our graph. Shows all the relevant features, shows where it is concave up, concave down, shows that it is decreasing everywhere. Note that it is going down from left to right no matter where you look. Shows where the inflection points are, shows where the isotopes are. That is enough. And I think we'll stop there.